Math people, today's lesson we're looking at solving one-step equations, and this time it's going to be involving fractions that are both positive and negative, and specifically addition and subtraction problems that involve negatives. So like I said in other lessons, and like you probably already know or should know, when you're solving any type of equation, whether it's with positives, negatives, whole numbers, non-whole numbers, you're going to be using inverse operations, and we've likened that to the concept of a scale, right? You want to keep both sides balanced, and you're going to be removing stuff until you have the variable isolated by itself. And if you want to remove something, like in this equation, to get rid of something, you do its inverse. Inverse operations cancel out. So the opposite of -2 is +2, and those two things just cancel each other out. But we took something off of this side of the scale, so to speak, so we need to do the same thing to the other side to the scale to keep it balanced, and that's how we will end up with our final answer. So let's jump down to our fraction problem examples, and that's what we'll go through today. So the first one, we've got z plus 3/2 equals 1/2. So I already know that my inverse operation in this example is going to be to subtract, because currently I'm adding and I need to get this out of the problem so that I have z isolated by itself and I have z equals. So I need to get rid of 3/2. Inverse of plus is minus. Those cancel out. Whatever you do to one side, you do to the other side. So here I'm going to be subtracting 3/2 from 1/2. So 1 minus 3 is -2. And you always keep the denominator the same when you add or subtract. So it's -2/2, which in other words is -1. So that means the answer to this equation, and we could check for reasonableness, is what plus 3/2 is 1/2? Well, -1 plus 3/2 is 1/2. That makes sense. I need to add a negative to this to make it get smaller, to get it down to 1/2. All right, so do two more and call it a day. In this example, I'm again going to be using subtraction as my inverse operation. That's going to get rid of the 2/3 that's with the variable q, and that's going to isolate q by itself. So I've got q equals, and I'm going to be subtracting. Now, when you add and subtract fractions, what's the number one thing you have to have? Common denominators. So for this subtraction problem, the first thing I need to do is make sure that my halves and my thirds turn into something common. If I multiply this fraction by 3 and this fraction by 2, I'll have a common denominator of 6. So I'll rewrite that. It's going to make it 3/6 minus 4/6. The denominator stays the same. 3 minus 4 is -1. So there's my answer here. -1/6 is what q is equal to. And that would be the solution to my equation. So I used inverse operations, canceled that out, did the same thing to this side, had to do a little work over here on the side just to get common denominators and subtract, and there we go. Last example, and then you're off on your own. P minus 3 1/6 equals 2.5. So I know my inverse operation is going to be addition. I'm going to be adding. That's the opposite of subtract. And I'm going to add that over here. And so now I have P equals something. And I'm going to get that something. I'm going to do -2.5 plus 3 1/6. But I need to get common denominators first. So I'm actually going to leave the second fraction the same, because 6th is good. I can turn seconds, halves, into 6th by multiplying by 3. So times 3. So this is really going to be -2 and 3/6 plus 3 1/6. All right, so this is an interesting one. I'm actually going to have to break this problem into parts because I have a mixed number. So I'm actually going to have to find the fraction answer, the whole number answer, and then put it all together. And I'll model that for you. I'll use two different colors. I'm going to do negative 3/6 because the first fraction is negative, plus 1/6. So negative 3 plus 1 is negative 2/6, or in other words, negative 1/3 if I simplify it. So I've got the fraction part. Now I'm going to do the whole number part, which is just negative 2 plus 3. So negative 2 plus 3, which is positive 1. So this is interesting. I have a positive whole number and a negative fraction. Now I have to put together the fraction and the whole number. So it's basically asking what's 1, and I'm putting things together, so I'm adding, plus negative 1/3. So I'm joining the two parts of the answer together. And 1, which can be written as a fraction, 3/3, since this is a fraction in thirds. So 3/3 plus negative 1/3 is equal to 2/3. So my final answer here is actually positive 2/3, which seems really wonky, but when you're dealing with negative fractions, and in particular mixed numbers, you have to solve the problem in two phases, because sometimes what's going to happen is you're going to get the fraction component as one thing, like we got a negative, and the whole number component as something else, we got a positive. And if that's the case, you then have to combine those two things, which is going to get you a slightly different final answer than what you might think it would be. Had, on the other hand, these both been positive or both been negative, you would have just put them together. So if this had been negative 1 and this was negative 1/3, your answer would just simply be negative 1 and 1/3. Or if they were both positive, it would have been positive 1 and 1/3. But because you had a positive and a negative, you had to put them together and they offset each other a bit, which is why we have positive 2/3 as our final answer. So if you encounter mixed numbers, take your time, use this problem and what I said during it as a model, and you should be fine. So our final solution here is positive 2/3, and I'm going to call it a day on this particular video lesson. If you have any questions, feel free to reach out. Otherwise, happy doing math. Bye-bye.